Here, we turn the regulated supply chain use case into an enterprise fabric blueprint. We'll connect organizations, channels, chain code, private data, APIs, and integrations into one architecture built for real deployment, governance, security, and compliance. We've already built the ingredients: fabric foundations, application development, and production governance. Now we'll combine them into a reference architecture for a regulated supply chain network. The focus is on turning concepts into design decisions before moving into deployment, compliance, and the capstone solution. Before choosing channels, peers, APIs, or chain code, we need principles that keep the architecture aligned with business reality. A regulated supply chain must let competitors and partners trust shared facts without giving control to a single operator. It must protect sensitive data while still producing evidence auditors can verify. And it must separate workflows, private information, and integrations so the platform can scale, stay highly available, and meet governance and compliance needs over time. Topology design begins with the consortium, who participates, and what each organization is allowed to do. In Fabric, each participant should be modeled as a separate member, with its own MSP, certificates, peers, and administration. Manufacturers or distributors may endorse high-volume transactions. Regulators and auditors may need strong visibility, but limited right authority. The key is to separate trust boundaries. Consortium rules, organization control, application permissions, and infrastructure operations should not be treated as the same thing. Identity is the control point for trust in Fabric. Each organization defines an MSP that determines which certificates, admins, peers, clients, and applications it recognizes. Certificate authorities issue enrollment and transaction certificates, linking real enterprise users to network actions. Attributes add business meaning, such as inspector, regulator, shipper, or manufacturer operator. Identity also has to be managed over time through onboarding, renewal, revocation, and offboarding, so permissions remain current and auditable. Start with the broadest channel that supports the shared supply chain process. Asset lifecycle, custody transfers, and common audit history usually belong in one primary ledger. Add another channel only when participants, rules, or governance truly change. Otherwise, each new channel creates more administration, integration work, and reconciliation risk. If the same transaction should be visible but certain fields are sensitive, use private data collections. That provides shared proof with restricted details. In this topology, peers provide the business-facing capacity, while the ordering service provides shared sequencing. Organizations that create or validate important transactions run endorsing peers, and anchor peers keep cross-organization gossip connected. Once transactions are endorsed, they move to multiple orderer nodes, forming a highly available ordering layer across failure domains. Blocks are then distributed back to peers for commit. Separating production peers from reporting or API-heavy peers helps protect transaction performance from query and integration load. Good chain code architecture starts with clear business boundaries. Rather than one large contract handling everything, create modules for lifecycle, custody, inspections, certifications, and recalls. Each module owns a focused set of transactions and makes state changes explicit, so auditors can trace what happened and why. Shared libraries should handle cross-cutting concerns like validation, authorization, events, and serialization. This keeps interfaces stable, easier to version, and easier for enterprise APIs to consume. Each regulated asset can be viewed as moving through a controlled state machine. A batch is created, ownership changes, shipment begins, receipt is confirmed, inspection occurs, and the asset is eventually distributed, retired, disposed, or recalled. Every custody transfer should capture who sent it, who accepted it, when, where, and in what condition. Chaincode validates each transition against permissions and business rules, then emits events for created, delayed, damaged, or quarantined assets. Now consider contamination detected in batch A104. The lab records test results against the batch and asset IDs, including inspector identity and time. Chaincode can then drive certification decisions: issue, renew, suspend, or revoke based on verified evidence. If risk crosses a threshold, a recall workflow identifies affected batches, notifies distributors and regulators, freezes transfers, and tracks remediation. High-priority events make failures, revocations, and recall initiation visible immediately for audit and response. A strong privacy model separates what the network must verify from what each party must protect. Shared facts, such as asset identity or custody status, can live on the ledger. Commercial terms, inspection details, and pricing usually need restricted access. Large documents and regulated records often stay off-chain, with hashes or proofs recorded on-chain. Personal data should remain inside controlled enterprise systems whenever possible. The goal is selective transparency, enough visibility for trust without exposing confidential or regulated information. Private data collections work well when only certain organizations should see sensitive fields. Large documents, however, should usually stay off-chain, encrypted in a document repository. Fabric records the hash, metadata, reference, and timestamp on the ledger. This gives everyone proof that the document existed and has not changed, without exposing its contents. Access is then controlled through applications, encryption keys, and regulator views, so each party sees only what it is authorized to inspect. Enterprise users and upstream systems should not call peers directly. They should enter through business APIs, where the gateway authenticates requests, applies rate limits, validates payloads, logs activity, and routes traffic. Behind that layer, application services convert actions like asset creation, custody transfer, inspection, certification lookup, or recall into Fabric transaction proposals and queries. Keep application roles aligned with Fabric identities and chaincode rules, but manage them separately so business access remains clear, auditable, and controlled. In production, Fabric should not operate as an isolated ledger. Chaincode and block events are published into a streaming layer, such as Kafka or cloud messaging, where downstream systems can react reliably. ARP, warehouse, transport, quality, and compliance applications consume those events to stay synchronized. Analytics consumers build read models and feed data lakes or dashboards. Large documents remain in secured storage, while hashes and references on-chain preserve integrity and auditability without overloading the ledger. A production-ready Fabric architecture is not the result of one decision. It comes from aligning roles, trust boundaries, identity, peers, orderers, and channels. Chaincode should mirror the real supply chain: asset lifecycle, custody transfer, inspection, certification, and recall. Privacy must be intentional, using channels, private collections, hashes, off-chain documents, and selective disclosure. From here, we move into deployment, operations, governance, compliance, and then the capstone solution design.